Hi everyone, welcome back to the show. Today we are diving into a topic that plays a huge role in aviation safety and design: instability in aircraft. It is something pilots and engineers are always aware of, and today we will break down what it really means and why it matters. Let's start with something called Dutch roll. What is Dutch roll? Dutch roll is a type of instability found in aircraft, especially jet aircraft with swept wings. It is a mix of two movements, yawing and rolling. The yaw itself isn't so dramatic, but it causes the aircraft to roll, and that is where things can get unstable. The plane starts rocking side to side, and this motion can repeat itself unless it is corrected. So, what causes Dutch roll? The root cause: swept wings. When a yaw starts, either from a disturbance or control input, things get out of balance. The outer wing moves faster through the air and ends up with more lift. Meanwhile, the inner wing moves slower and loses lift. That imbalance makes the aircraft bang. As the wing with more lift stalls, the balance flips and the motion reverses. The result: an ongoing seesawing motion with called Dutch roll. Recovering from Dutch roll. If the aircraft doesn't have working yaw dampers, the pilot can recover using ailerons, basically rolling the aircraft in the opposite direction of the roll. But here's a key point: you don't want to use the rudder. That might seem counterintuitive because the Dutch roll starts with yaw, but rudder inputs usually make things worse. The yaw happens so fast that by the time the pilot reacts, the plane is already rolling. Using rudder can turn the situation into a full onside slip. Aileron control is the safer move. How do we prevent Dutch roll? The main tool is a yaw damper. It is a system that automatically corrects yawing motion before it builds into a Dutch roll. The problem really comes down to the wing sweep and not having enough tail fin to keep the aircraft directionally stable. Instead of making the big fin, which would hurt other flight qualities, we use yaw dampers to handle the job. Directional stability. This is an aircraft's natural ability to return to its original heading after being knocked off course. It happens thanks to the vertical tail fin, which creates a restoring force when the aircraft yaws. Spiral stability versus spiral instability. Here's another angle of stability to think about. If a plane is spirally stable, it will naturally level out of a turn when the pilot lets go of the controls. But if it's spirally unstable, the turn can tighten up fast. The nose drops, speed increases, and before you know it, the plane's will diving in a spiral. That is usually due to having a vertical fin that is too dominated. The fin tries to straighten out of the yaw, but in doing so, it actually increases the roll, and that kicks off a dangerous feedback loop. Lateral stability. This kind of stability keeps the wings level. It's helped by two things. First, a wing lateral. That upward angle of the wings helps the aircraft roll back to the level during a side slip. Second, side loads on the keel, especially on the fin. These help produce a rolling moment that also stabilizes the plane. It is a small effect, but it adds up. Longitudinal stability. Now we are talking pitch, the nose moving up or down. Longitudinal stability means that after a pitch disturbance, the aircraft wants to return to its original flight altitude. The tailplane plays a big role here. When the nose pitches up, the tailplane pushes its back down, restoring balance. As long as the center of gravity stays within limits, the system works naturally. Stability at high altitude. As aircraft climb, stability takes a hit. Aerodynamic damping gets weaker and the plane feels less stable. However, spiral stability actually gets better with altitude, while oscillatory stability, like the Dutch roll, gets worse. That is because the air is thinner, the fin loses effectiveness, and the wings become more dominant. 4 flying penalties at high altitude. At very high altitudes, aircraft face 4 key limitations: a narrower speed range to safely operate in, less maneuverability, weaker aerodynamic damping, overall reduced stability. That wraps up our deep dive into the aircraft instability today. In the next episode, we will talk about control surfaces, what they are, how they work, and why they are vital for flying safety. Thanks for listening, and if you found this episode helpful, don't forget to subscribe and share it with your fellow aviation enthusiasts. Catch you next time.